Hi everybody, this is Mrs. Ellsworth, and today we're going to be talking about prisms. I know that I've got a picture of a pyramid on there and also a prism, but we're going to be talking about prisms just for this lesson right here. And the prisms will be for lesson 10-1B, and your problems will start on page 561. This lesson starts on page about like 559 or so. And I'm actually going to do a couple of the problems that you've got due. And then once you do those problems, then you need to go and put them there inside your book. And so then once you do them, then you can add them to a Google form. Just put your answers inside that Google form so I can get some feedback, and you can get feedback on what you're doing right and what you're doing wrong. Hopefully you're getting it all right, right? Anyway, so let's go ahead and look at this. When we are talking about a pyramid versus a prism, drawing lines from one point up above a rectangle. This is one that's kind of slanted because of course we're looking at it from afar, and so you could put dotted lines on the ones in the back if you want. They're behind them, that's fine too. But notice that all of the sides in this are all triangles. Okay, so pyramids, all the sides go up to one point and that they're all triangle sides. Okay, you could also have a rectangular base prism too, but you could also have a triangular base prism. Okay, and so like here's a triangular base building type one, we'll say. And so now I'll draw the sides. So I got my two bases, and it's important that you recognize this so that you can tell the difference between the pyramids and the prisms. Okay, so there's a triangular base prism. Notice that the top and the bottom are identical. Okay, that you've got two triangles, and all the sides are all rectangles. Okay, now let's go and look at one that'd be like a roof of a house or a pup tent or something like that. So this one's laying on a side. This one is standing up on its triangular base. This one's going to be laying on a side, and we'll do the skew it a little bit there. And so here we go with some lines. We'll connect all the apexes here. Oh well. Anyway, so as you can see that this is facing towards you, that one's in the back, and so you can see you got two triangular bases, and then all the sides are the height of it, and they are all rectangles. So that's probably the easiest way to tell the difference between the two. I will post a small little like minute-long video where this little kid is explaining the two difference between them, and so you can check that out too if you'd like to have some extra help with those. Also, Math Antics I'll post something on there for volume for you too. Okay, so let's look at a rectangular base prism. Now, if you look at the volume formula, this is our volume formula, and we'll use this every single time, but we're going to have to insert something for the area of the base. In the case of this base right here, you know, is a rectangular base prism. So lots of people do length times width, and that's fine. Here would be your formula for that. Okay, so you got length times width for the area of your base, replacing B, and then here's the height of your whole prism. Okay, and so let's look at it for Minnesota standards. Okay, we would do, instead of the length times width, we would do base times height. This is the base and the height of just this base. Okay, what it's sitting on, and then the height right here. Okay, and that's the nice thing about rectangular base prisms, because you're just taking all three of the values that you're given and you're just multiplying them together. But the area of the base of the base is 5, and then the height of the base is 4. You can switch them around, of course, it doesn't matter. And then the height is 3. So you'll get 60 cubic centimeters. Notice we got that cube there, meaning that we've taken 3 and we've multiplied them, so you've got to the cube, and also meaning that it's three-dimensional. Because the areas of all those figures that we did yesterday were all just two-dimensional. They were flat. Okay, let's look at these two boxes. Typically, the younger that the student is, they'll think that the taller something is, the more volume that it is. It's kind of an intuitive thing that they believe. And so these ones are all rectangular base prisms. And so I will, either you're going to go with length and width, or else you'll go with base and height, which I will. Here's our formula. Okay, so for the box A, notice our base is 3.5 times 3.5. Okay, and then our height of that whole thing is going to be the 5 inches. This is nice because rectangular bases, you can always pick which one is your base, and we usually like the one that is sitting on. Anyway, you get 61.25 cubic inches on that, and this one will say round to the nearest whole number, so it'll be 61 cubic inches. Okay, box B. Box B will use the same exact formula, but you'll notice it's 4.5 times 4 for the base. And it's got a height of also 4. And so you multiply it all out and you get 72 cubic inches. And that is definitely got, box B has definitely more volume than box A. Okay, moving on. Okay, a triangular base prism. Sometimes it is very hard to see the triangle in these. Like I said, students will confuse them for pyramids once we start talking about pyramids too. But look, and do you have two triangle bases? If you only got two of them, that means it's a triangular based prism. Notice that this one also shows you the height of the triangle. If you go and tip your head to the right a little bit, you'll see that this is the height of that base, that triangle. Okay, and it's got that perpendicular line showing that's perpendicular to the base. So here would be our little b for the area of the base. And here to be our height. Okay, and so I go and I for this area of the base, I go and just plug it all in there, and I use this formula. So put that on your formula sheet. That's great, and that's what I will use. So here is my area of the base, and the height of the base, and then we also have the height of the whole prism. And I designate that always with a capital H in all of the things that I show you guys because it's, well, because you get two small h's otherwise. So the whole big thing I always put with a capital H. Okay, here, let's go through an example. Well, with this one right here, you notice you've got triangular base. So this is not a base that's a rectangle. Okay, it's got a triangle. So we'll go ahead and substitute in for B. We'll substitute this area of the base, and I use this formula again. Okay, and notice that the base is going to be 1/2 times the base, which is 4, base of the base, and the height of the base, which is 5. And then you're going to take it times the height of the whole thing. Now, even though this one's laying down, okay, that is the height of it. So it's always a rectangular side that you're always measuring there. So watch out, make sure that it's not one of these triangle sides and that it's the height of the whole thing from one triangle base to the other triangle base. It'd be 5.2 in this one, which would be no big deal because you guys got calculators, but in this case it's 7. And so you go multiply it all out and you will get 70 cubic inches, that should be. Okay, moving on. Here's some of your problems for your homework. So notice that that this one right here would be for a rectangular prism, and this one right here would be for the triangular base prism. So here at the top two here, 1 and 2 are a rectangular base. We're going to do number 2, okay, and then I think we're going to do number 7. Yeah, number 7. Okay, so here's again, volume is area of the base times the height, area of the base times the height. So in this case, for number 2, we've got 3 times, well, I should have done 2 here, but I went and had this front side as the area of my base. Okay, so, oopsie, spoiler alert. Okay, anyway, so I just take those 3 sides and I just have to multiply them. That's a nice thing about rectangular base prisms. And so then we'll get 30 cubic millimeters. Okay, then let's go ahead now and take a peek at this triangular base prism. Okay, here's our height of the whole prism. Here's our base of the whole prism, and here's our height of the base. Okay, height of the base, base of the base. Okay, so we get 0.5 times 7 times 3, and then times the height of the whole thing, which is 6. Okay, and then when you multiply that all out, you will get 63 cubic yards. Okay, again, it's cubic because it is a volume. Okay, and on your other homework, you'll be finishing this. You don't have to do, let's see, you don't have to do 5, and you don't have to do 6. Okay, and I already did 2 and 3 for you, so that's pretty nice. So you're skipping 6, and so of course this is the formula for rectangular base prisms. Okay, and then you've got the formula for the triangular base prism. Notice your height. Your height. Those ones are sometimes kind of hard to pick out. Now, yeah, and all these triangular bases on here, can you see them on here? Here's a triangle base, 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 base. Even though it's not sitting on it, you definitely just have 2 triangles and the rest are all rectangles. Okay, now as soon as you're done with these problems, I want you to remember to go and put it into your Google form. That'll be also put onto Google Classroom too in addition to this. And I only just have one other worry, and that's if you were given fractions, that you could go and put them by using your fraction buttons in your calculator. You could put them in there, or else you could recognize that this is 5.5, 2.25. So don't let those fractions freak you out, and just use your calculator and figure them out. Okay, and I will be looking for your answers on the Google form, and I will see you when I see you. If not, I will see you online soon, tomorrow. Bye-bye.